Welcome back to Teen to ND. When you see a headline about a new scientific breakthrough, what do you picture? These, a diet that extends life, a new technology that changes everything. Science in the popular imagination is a series of incredible successes. What if the most important stories in science are the ones you never hear about? Today, we're diving into the hidden world of missing data, the studies that find nothing, the experiments that fail, and why they mysteriously disappear from the public record. This is the story of the file drawer effect, and it shapes everything from the medicines you take to the policies that govern our lives. Let's start with a simple idea. When researchers design an experiment, they start with a hypothesis. For example, this new drug will lower blood pressure, or this teaching method will improve test scores. They then collect data to see if the hypothesis holds up. If the drug works or the scores go up, that's a positive result. It's exciting, it's novel, and it's what we typically see published in journals and reported in the news. But what happens if the drug does nothing? What if the test scores don't change? This is what's called a negative result. It doesn't mean the study was bad or that the science failed. It simply means the data did not support the initial idea. In an ideal world, this finding would be just as valuable. Knowing what doesn't work is crucial. It stops other scientists from wasting time and money chasing dead ends. It helps refine our understanding of the world. A negative result is still a result. The problem is, our scientific system doesn't treat all results equally. This brings us to a huge issue known as publication bias. Scientific journals, the gatekeepers of research, have a strong preference for positive, statistically significant findings. A study that shows a dramatic effect is seen as more interesting, more impactful, and more likely to be cited by other researchers. A study that finds no effect is often seen as boring, inconclusive, or even a failure. Think about it from a journal editor's perspective. They want to publish research that gets people talking, that pushes the field forward. A paper titled "New Compound Dramatically Shrinks Tumors" is a lot sexier than one titled "New Compound Has No Effect on Tumors." Even if both studies were conducted with perfect rigor, either "New Compound Has No Effect on Tumors." Even if both studies were conducted with perfect rigor, the first one is far more likely to get published. As a result, researchers who conduct solid studies with negative outcomes often face rejection after rejection. This isn't just about journals. The entire career structure of a scientist is built on a foundation of publications, grants, and citations. To get tenure, to secure funding for their next project, researchers need a strong publication record. This creates a powerful incentive to find positive results. A scientist might have 10 different research ideas. If none of them produce negative or null results and only one produces a positive one, which one do you think they'll focus on writing up and submitting for publication? This leads directly to what's called the file drawer effect. It's a great name for a serious problem. Imagine a researcher's office. They get stuffed into a file drawer never to see the light of day. They aren't necessarily hidden out of malice. The researcher might just think, no one will publish this anyway, so why bother writing it up? Now multiply that one file drawer by thousands of researchers all over the world. The result is a scientific literature that is systematically skewed. It's like trying to understand a sports team by only watching their highlight reels. You'd think they never miss a shot, never make a mistake. The reality is far more complex. In science, this skewed picture makes treatments and effects seem much stronger and more consistent than they actually are. This has profound consequences. One of the most powerful tools in science is the meta-analysis. This is where researchers gather all the published studies on a specific topic, say, the effectiveness of a particular antidepressant, and combine their results to get a single robust conclusion. But a meta-analysis is only as good as the data it includes. If all the studies showing the drug didn't work are sitting in file drawers, the meta-analysis will only include the positive ones. The conclusion? The drug will appear far more effective than it truly is. This isn't a theoretical problem. It happens all the time, and when it involves medicine, the stakes are life and death. Imagine a new drug is tested in 20 clinical trials. Let's say 10 trials find it works, but the other 10 find it has no effect or even has harmful side effects. If only the 10 positive trials are published, doctors and regulators will see a very rosy picture. They might approve the drug and prescribe it to thousands of patients, based on incomplete and therefore misleading evidence. The information that was hidden in the file drawer could have protected patients from an ineffective or even dangerous treatment. This isn't just about scientific accuracy. It's an ethical crisis. So what are we doing about this? The good news is that the scientific community is aware of the problem and is starting to take action. One of the biggest reforms is the creation of clinical trial registries, like clinicaltrials.gov. The idea is simple. Before a study even begins, researchers must publicly register it, outlining their hypothesis and methods. This creates a public record of the study's existence, regardless of its outcome. It makes it much harder for negative results to just disappear. If a study is registered but never published, other scientists can ask why. There's also a growing movement for open science and open data. This encourages researchers to share not just their published papers, but their raw data and full methodologies. This level of transparency allows others to reanalyze the findings and catch potential biases. Some journals are also changing their policies, creating specific outlets for negative results or replication studies, which test whether a previous finding can be repeated. They're recognizing that a well-conducted study is valuable, no matter what it finds. But these structural changes are only part of the solution. We also need a cultural shift. We need to move away from celebrating only the breakthroughs and start valuing rigor, transparency, and honesty. We need to redefine scientific success. A researcher who conducts a flawless study that finds no effect has contributed just as much to our knowledge as one who finds a positive one. In fact, they may have saved us from heading down the wrong path. The missing data problem is a subtle but powerful force that distorts our understanding of the world. It shows us that what we don't see can be just as important as what we do. Science is not a linear march of triumphs. It's a messy, complicated process of trial and error. And error, or rather, the honest reporting of it, is not a failure. It's a fundamental part of how we learn. By bringing negative results out of the file drawer and into the light, we make science slower, less glamorous, but ultimately much more reliable and trustworthy. Thanks for watching. If you found this look into the hidden side of science interesting, please like this video and subscribe for more deep dives. See you next time.